Assalamualaikum and hi to our lecturer and friend. My name is No Aklima binti Muhammad Asmadi. Me and my groupmate gonna present a few questions about building technology part 2. First question is a method of curing of concrete for the building frame and structure. One of the most versatile and often utilized building material by numerous building is concrete. Concrete is a building material made up by cement, water, and aggregate, a powerful and chemical practical component. Concrete is primarily made up of 4 ingredients, which is a cement, sand, water, and gravel. Concrete is therefore created when a cement, aggregate, and water are added. The chemical reaction between water and cement is called the hydration process. Consequently, the concrete gets stronger and harder as a result of the hydration process. This gonna take time since the concrete takes around 28 days after casting to reach its final strength. Concrete may be cured using a 5 distinct method of curing concrete, which is the bonding, fogging, spraying, steaming curing, and covering with a plastic sheet. Method 1 is bonding. Bonding method is one of the quick, inexpensive, and effective method of curing by the supply of good materials such as a clay soil, supply of the water, and the ponds. The concept of this method is pavilion slab, roof slab, and other ware kept underwater by making small ponds. To make a pond, build a little sand or 3 dikes around the perimeter of the concrete slab. The water will be retained by this dike and won't be able to run off the slab. The importance of creating a pond is make sure have no crack or any joints in the concrete to prevent leakage of the water. See ponded water evaporators. It is first important to periodically replacing the water to prevent dryness. Lastly, the temperature differently between the curing water and ambient temperature should not exceed 11 degrees Celsius to make sure have no tension that will create the cracking of bonds. The second method that can be used for curing the concrete is fogging. The process of fogging is need to use a misting equipment such as a fogging nozzle or atomizers. It's used to create a fog of water droplets. By the fog of water droplets on the surface of the concrete, surface temperature can be maintained cooler and also can reduce temporal stresses that lead to cracking of the concrete. Fogging method is the easy and quick to set up, especially for large and complicated access of concrete surface. On the other hand, the water that used in the fogging process must be clean, safe, and because to avoid stain or damage the concrete. To make sure the fogging method will effective to cure the concrete, it need to adjust its intensity depend of real-time environment condition. Next, the third method of the curing the concrete is the spraying method. Spraying method, or also known as a water spraying, is the process apply water by spray the water onto the concrete surface that function to maintaining the moisture of the concrete to dry on the right time. This process must do a multi-time per day, depend on the environmental weather and condition. The water's temperature should not to be much lower than the concrete temperature in order to avoid heat shock. The other method of curing concrete is steam method. Concrete sections are cured by the use of steam or water vapor in the steam method. This method is suitable used in the cool weather condition which is when the concrete needs more heat for hydration and a quicker illustrating RES. Steam method is one of prevalent techniques for precast RCC pieces. The precast members are kept within a chambers during large-scale concrete production at a factory. The process of this method was quick and almost utilized for large manufacture of the concrete member. By maintaining an ideal temperature, the steam curving method may achieve a 28 power of 10 standard curving concrete water in just 3 days. High pressure steam curving, or also known as after curving. Steam curving improves hydration by creating a controlled environment with a high humidity and temperatures, which can promote faster and more consistent strength development. Lastly is plastic sheet covering method of the curing concrete. The concrete surface is covered by plastic sheet in this method. It is applied immediately after the slab is done. It produces a first set that is entirely coated in a layer of the plastic. This helps with the curing pace by lowering the slab evaporative loss. In this method, temperature has a big influence. Therefore, the plastic covering must be selected. First, use the dark plastic if the temperature is below 60 degrees. Second, cover the concrete with a reflective white or metallic covering if the temperature climbs above 85 degrees. It is apparent that using plastic covering can help the concrete cure without breaking. Finally, there are several methods that may be utilized to cure concrete. Curing of the concrete can be defined as the important action that must be taken again to concrete to maintain the longevity, structure, integrity, and durability.
So for load transfers from frame and structures of the building to the ground, for overall explanation is when the process by which the weight and the forces that operate upon a structure are transferred from the building components to the ground, or we can call it as foundation. And in basic terms, load transfer from frame and structures of the building to the ground is also about how the building weights and any pressures that it carries supported and distributed through the structure to maintain its stability and also its safety. So even though a few of us might see that from here we have two kind of questions here, but actually the load transfers from frame of the building to the ground and the load transfer from the structures of the building to the ground are same actually. So it tells that the components of the buildings of the building structure are different. Like it may have different roles or even arrangement. So in a frame structure, loads are introduced into the structure through numerous processes such as vertical forces, which is an example is like gravity loading, and lateral forces, which example is such as wind and earthquake or other external forces. So next, let's talk about vertical forces and lateral forces, or another name we can call it as lateral loads and vertical loads. So yeah, what is vertical forces and lateral forces in details. First of all, lateral forces and vertical forces are the two basic types of loads that buildings and structures might face, and they are differ in their direction and effects on the structure. So firstly, for direction, lateral loads are live loads applied parallel to the ground, which horizontal forces are acting on a structure. So as we all have known, the most common type of lateral forces is wind load, and for vertical forces, the most common type of these forces are gravity loads, which are those forces that are applied perpendicular to the roof or floor system. So vertical forces are separated into two categories, which are dead loads and also live loads. Then for the effects on the structure, lateral forces typically will cause the structure to wobble, or even another name we can call it as move horizontally, especially when it comes to the design of high-rise building. They can cause bending, shear, or even rotational stresses in structural elements, which must be prevented in order to, of course, to maintain its stability and to prevent structural failure. So for vertical forces, these forces are the main causes of compression and tension with structural elements. So gravity loads, for example, will compress the structural element vertically, while the live load can cause both compression and tension depending on their distribution. So as we already know that basic explanation for load transfers from frame and structures of the building to the ground is important to ensure structural stability, safety, and durability. But here I will also explain about the importance of load transfer from frame and structure of the building to the ground in details. So for structural integrity, buildings are exposed to various kind of loads, including dead loads, which is the structure's weight, and live load like furniture, and environmental factors like wind and snow. And if we have proper load transfer, it can ensure that these loads are distributed. So for the next point is about safety. Safety is efficient load transfer mechanism that can ensure the structure can resist the forces exerted on it over its lifetime, and this is especially important during the disasters events, example like when earthquakes or strong winds, since it can help to ensure the safety of the people and can prevent the building or the structure from collapse, or even for structural damage. So next is about long-term durability. Long-term durability is when the building's long-term durability is influenced by effective load transfer. So it will extend the life of the building by preventing premature damage of structural components, and preventing premature damage of structural components can be done by distributing loads consistently and decreasing stress concentrations. Then we also have minimizing structural movement. So minimizing structural movement are like sway, deflections, and vibrations. So all of these three minimizing structural movement are among the structural movements that can be reduced with proper load transfer. So if the building or structure move too much, then the capacity that they can hold, that the building can hold or structure can hold, it can eventually weaken the foundational strength of the buildings components and cause the discomfort for people or animals like cats and dogs that are living in that buildings or in that structure. And lastly, for the importance of load transfer from the frame and structure of the building to the ground is foundation performance. So foundation performance is when the foundation of the building will depends mainly on load transfer. So the entire structure's rate of foundation performance is of course will be supported by the foundations, that which the load will be transferred to the earth. So and in effective load transmission might put a great deal amount of stress on the foundation, which could lead to maybe its failure or uneven settling.
For the last topic of the presentation, I will explain about dam-proof membrane and dam-proof cores. A dam-proof membrane and dam-proof cores are crucial components in building construction that prevent moisture transmission and dam-related issues in building. These waterproofing solutions are designed to stop moisture from seeping throughout the surface and help to ensure a dry, comfortable, and durable building structure. A dam-proof membrane is a thin sheet material typically made of polythene. This type of membrane material is used to prevent dampness from occurring throughout capillary action from the internal wall and floor of a property. Additionally, dam-proof membrane provide protection against a variety of problems associated with moisture ingress ranging from visible damp patches such as wet area on walls and floor to sub-damaged rot and mold. A dam-proof membrane is commonly used under concrete slab or floor to prevent moisture from passing. Therefore, a dam-proof membrane will ensure the protection of building structure from rising dampness, surface condensation, and other moisture-related issues. In the construction of the building, if a dam-proof membrane is not installed during the construction process, it will have a negative impact on the quality of building. Next, a dam-proof course is a barrier typically made of material like bituminous felt, copper sheet, or polythene that is inserted into the walls of the building to prevent moisture from rising through capillary action. Dam-proof course a crucial role in preventing dampness and moisture-related issues in building. The installation of the dam-proof course is a standard practice during construction to ensure the integrity of the building structure in the good quality and longevity of the building. Hence, it is placed at a height of 150 millimeters above ground level to stop dampness from penetrating the walls. Usually, a dam-proof course installed into the base of wall as standard during construction. This is because installing a dam-proof course is essential in protecting buildings from issues like rising dampness, mold growth, mildew, staining, and damage to surface finishes caused by moisture. Why a dam-proof membrane and dam-proof course is important in floor construction? A dam-proof membrane and a dam-proof course for floor construction is significant for preventing moisture-related issues and protecting the structural integrity of building. A dam-proof membrane and a dam-proof course widely used in building construction to maintain the quality of the building. Therefore, a dam-proof membrane and a dam-proof course have many importance in building structure, especially on the floor and walls. What the importance of dam-proof membrane? Okay, let me explain. The importance of dam-proof membrane is to preventing moisture ingress. One of the most important roles of the dam-proof membrane in construction is to stop moisture. A dam-proof membrane acts as a physical barrier to stop moisture from infiltrating a structure's internal walls and floor, and also protecting against various moisture-related issues. Other than that, a dam-proof membrane also protects building from a variety of problems by preventing moisture, including the growth of mold, fungus decay, salt contamination, cracked plaster, discolored walls, and structural issues brought on by dampness. Furthermore, a dam-proof membrane helps maintain a safety and healthy indoor environment by preventing musty outdoor, decreased property value, and damp-related health concerns. Next, the second point is to maintaining structural integrity. The dam-proof membrane is essential for maintaining structural integrity of building by preventing moisture-related damage. A well-maintained dam-proof membrane ensures that moisture will not adversely affect the building's performance or structural stability over time. Therefore, a properly installed dam-proof membrane can prevent moisture from weakening the material, reducing the risk of cracking, rotting, or corrosion. This is because moisture can cause serious damage to various building materials such as concrete, wood, and metal. A dam-proof membrane is a crucial component in protecting the overall health and stability of a structure. The importance of installing a dam-proof membrane is enhancing safety and health. Dam-proof membrane help maintaining a safe and healthy indoor environment by preventing moisture ingress, which help prevent problems like musty outdoor, decreased property value, and healthy issues related to dampness. Additionally, building dampness can encourage the growth of dangerous microorganisms like mold and mildew, which can lower indoor air quality and endangers occupant health. Hence, a dam-proof membrane is act as reducing the risk of health problems. Next, we move on the importance of dam-proof course. The importance of dam-proof course is preventing rising damp. By installing a dam-proof course is crucial because can prevent water from moving vertical upward through porous wall like concrete floor. Dam-proof course installed into ground level can protect the building from moisture infiltration. Hence, by installing a dam-proof course is important because it can also protect the structural integrity and prevent the increase in moisture that can cause structural damage in the building. The second point is protecting walls and floor. The dam-proof course is important because it acts as barrier to keep moisture out of walls and floor, avoiding problems like mold development, contaminated soil, and dampness-related structural damage. This can increase the value of the buildings because less dampness can enhance the value of aesthetical of building structure. Other than that, reduce the maintenance cost of the buildings. This is because buildings with dampness issue often require expensive maintenance and repair to address structural damage, replace damaged materials, and stop the growth of mold. The last point of the important dam-proof course is comprehensive dam-proofing. The combination of a dam-proof membrane underfloor and dam-proof course in walls will provide comprehensive protection against moisture ingress, ensuring the building keeping it dry, secure, and structural sound. Hence, to completely prevent moisture problem, the dam-proof course should be continuous with any dam-proof membrane on the floor. That's all from me and my group mate. Thank you for lending your ear and your attention.